So let's talk a little bit about operations with functions. And the operations that we're talking about here are just our basic four: addition, subtraction, multiplication, and division. But we better make sure we understand what a function is, or at least a kind of a general idea of one. Both of these are written in function notation. We have our f of x equaling some rule. Okay, and a function is just something that you kind of can plug an input in, and then the output comes out. So we have a place where we can put any number or variable, and then that would be our input value. And then the f function here, right, the one in red, it's going to take whatever value you give it, and the rule says to multiply that value by 2 and then add 1. For our g function down here, the green one, again, this is g of x equals negative 5x plus 3, and our input value would be represented in this area, and then the rule says to take that value, multiply it by negative 5, and then add 3, and then that value would be your output. So let's go through some of the basic operations here, and one of the ways it can be written would be f plus g, when we're talking about addition here, of x. Okay, well that simply is saying take whatever the f function is and add it to whatever the g function is. Okay, and we're just going to do some simple substitution in here because we already know what our f function is. Right, we're going to put that there, and then we also know what our g function is. We put that there. So I'm going to rewrite this as the f function, which is 2x plus 1, and we're going to add the g function to it, which is negative 5x plus 3. Okay, so this operation is just telling us to combine all like terms. We just want this into a condensed form. So we got to remember what your like terms are, and that like terms have the exact same variable setup, and then all you're doing is adding, in this case, since we're adding, the coefficients. So we have this set of like terms, and then we have these like terms. So we're just going to combine those together. 2x plus negative 5x would be negative 3x, and 1 plus 3 is 4. So f plus g of x is equivalent to negative 3x plus 4. So let's move on to another operation that we can do, which would be subtraction. So we have f minus g of x, and again, all that's telling us to do is take whatever the f function is and subtract the g function away from it. Now be careful whenever you're doing anything with subtraction signs. Remember that you really got to pay attention, because you're probably going to end up distributing a negative 1 to everything, which we will do here. So let's just substitute in our information. And so our f function is 2x plus 1. We're going to subtract the g function. And basically it's the same as the addition of functions, except this negative is going to affect everything that comes after it, because we're talking about a whole quantity, the whole g function. Okay, so I'm going to rewrite this as 2x plus 1 plus 5x minus 3. And now I'm just going to combine like terms. 2x plus 5x is 7x. 1 minus 3 is minus 2. So f minus g of x would be 7x minus 2. Now make sure you understand that if we switch the order here, if the question was asking for g minus f of x, that would give us a completely different answer down here, because of the way the negative sign would react with the f function. But f minus g of x, right? Just be careful. So let's take a look at multiplying functions together. And so that could be written as f times g of x. And again, all we're doing is substituting in whatever information the f function is, and then we're going to multiply that by whatever the g function is. Now you got to remember how to FOIL in a lot of situations, maybe not all of them. But again, the f function is 2x plus 1, and the g function is negative 5x plus 3. And remember, when you FOIL, right, that means you're distributing every term to every term here. So 2x times negative 5x would be negative 10x squared. 2x times 3 would be positive 6x. Then we're going to take the 1 and distribute it to both terms. 1 times negative 5x and 1 times 3. Now we're just going to combine any like terms. So we would get f times g of x as negative 10x squared plus x plus 3. So for the final operation of the basic 4, we're going to do the division. So f divided by g of x. And so that means we're going to take the f function and put it in the numerator, because division is just, fractions and divisions are the same thing. And we're going to take the g function and put it in the denominator. And that's just, the way the problem was set up. I'll do another example where we divide it the opposite way. But this is really simple, because a lot of the basic the basic functions that you'll be dealing with, there's really not a whole bunch you can do. So we're just going to substitute in. Now there's a whole bunch of information about how to simplify rational expressions, which is what this is. But you have to do it by factoring, and so these two things are you just leave them alone. There's nothing that you can really do with them. There's nothing that can be simplified. Now you should understand a little bit something about domain, and domain is the x values of any function, and usually the domain is just all reals, because there's really usually no limit of what you're allowed to plug into a function. But when you have a denominator, and a variable in that denominator, there are sometimes one or more values that could change the denominator to 0. And in this case, there's just one value, and you can find that pretty simply if you just take that denominator and set it equal to 0 and solve. You get x equaling 3/5, but that's what x cannot be for the domain. So the domain would be all reals except for 3/5. But if you're just asked to divide, that's all you're doing with the division. And usually you should state what the domain is. So for the final example that I'm going to do with the operations here, the 4 basic operations, I'm just going to do g divided by f this time, and it's the same process. I just want to show that it's different. This time the g information is going to be in the numerator, and the f information will be in the denominator. So again, when you're dividing, nice and easy, you just plug in the numerator and plug in the denominator, and then that's done. But now our domain has changed, which is why I wanted to do this. And so if we take our denominator, set it equal to 0, and solve, we'll see that the domain can be all reals, except now it cannot be -1/2. So those are the 4 basic operations that you can do with functions. Should be pretty straightforward.